All right, today we're going to revisit shifts, and we're also going to talk about reflections and symmetry of functions. So if you recall back in chapter 1, we looked at horizontal and vertical shifts to a function. So if you take a function, let's say f of x, right, and you add something to the output of that function, it's going to shift the function up or down, depending on the sign of this k value that we're adding to it. So if k is positive, we would shift it up, right? Because we're taking every output value and adding something positive to it. If k is negative, then it would shift it down, right? Because then we're subtracting something from the output of the function. So this k value controls the vertical shift. It shifts the function up or down. We also looked at horizontal shifts. And horizontal shifts work a little bit counterintuitively. So, but we saw in chapter 1 that this h, right? If we modify the input to the function and we subtract a value from it, if we subtract a positive value from it, then we're going to shift the function to the right, all right, in the positive direction, but we're subtracting it, right? So if we subtract a negative, which means we're adding something to the function, then we shift it to the left, okay? So h controls the horizontal shift, horizontal shift, and this k value controls the vertical shift, okay? So let's just take a look at this first example. And we have a function f of x. The f of x function is the dashed line. And it goes through 0, 0. All right, so it looks like some sort of maybe cubic function. And it's passing through 0, 0. And then we have a translation of that function that passes through 5, 3. And we're asked to give a formula for g of x in terms of f of x. All right, so we just need to figure out, okay, what are the shifts going on? It looks like we're shifting, we've got a vertical shift, right? If I actually, I'm going to get a different pen here. Let me do red. All right, so it looks like we're shifting, we're taking this point 0, 0, right? And that becomes a new point on the new function. So we're shifting up 3. Whoops. Hang on. All right, up up 3. And we're going to the right. We're going to the right by 5, right? So so the we're shifting vertically up by 3. So that means that, so we go up by 3. Actually, let me switch back to green. We'll go up 3, right? And we're going right by 5. Okay. So this up, shifting up and down is a vertical shift. So that means that k is equal to 3. We're shifting in the positive direction. And a shift to the right or left is a horizontal shift. So this means that h is equal to 5. So we don't know the formula for f of x, but we can write a formula. We can write a formula for g of x in terms of f of x if we just substitute the h and the k value. So we can write g of x is equal to f of x shifted to the right by 5, right? So that's a minus 5. Remember, it's a little counterintuitive, right? It's kind of a minus here. H is 5, but there's a minus in the formula up there. And then we're adding 3 to the output of that. So shifting it up by 3. So that's the answer right there. It's a little counterintuitive. I like to think of it in terms of input and output. So if you were to draw a, sort of a, I don't know what to call these diagrams, sort of a function diagram, the function diagram where here's our f of x, right? We give it an input, and we know that if we give it 0, it will give me an output of 0, right? the plain old f, right? Plain old f of x, because that's the dashed line, so it passes through 0, 0. All right, but that is shifted up by 3. So we're going to take the output of f of x and we're going to add 3 to it, which will give us the 3 out. Okay. Now on the other side, we want to be able to give it, 5, right? And then get 3 out. So what do we have to do to 5 to get 0? We have to subtract. So we're going to subtract 5. Okay. So sometimes it helps me at least see a little bit better, especially that the inside change, right? Where you're doing something to the input. It's a little counterintuitive, but sometimes that diagram helps me. So, all right, I will meet you in the next video for the next example.